So hi everyone. So today I'm going to explain you our project, the GreenBIMxels project. Not really easy to pronounce. And the ontology that we have developed on this project, which is the BIMxel, a semantic hub for sustainable public buildings. So, so when addressing public facilities, we always have the same problem that public administrations, they have a wide amount of data that they are never using to manage their own portfolio. So the idea is that in this project, we connect all the data that public administrations have through a data space. That's the way they have some governance over the data, and we can also get profit of this information, be able to do analysis. We are also facing other problems, such as the fragmented ontologies that we have nowadays. So, okay, how do we structure this data? The idea is that we develop this BIMxel, this new kind of ontology, but based on the existing ontologies that exist nowadays, like BOT, SAREF, GeoSparkle, etc. And also, we address the interoperability gaps, meaning that we have inconsistent vocabularies across different systems, across the BIM models that we get, or the IoT systems that we need to manage the buildings. At the beginning of the project, we were working with 6 administrations. Now we are working with around 15 public administrations, and we are working on 3 main case studies that are energy efficiency, water consumption, and carbon footprint. And the idea is to build this interoperable data ecosystem connected to the data space to help managing the performance of their building portfolio. The 3 case studies, what we aim to improve with them are for energy efficiency, basically real data analysis, anomaly detection, and digital twins to reduce the consumption. For sustainable water consumption, we have seasonal analysis, real-time monitoring, also the anomaly detection, which is something that for public administrations is really important. And for carbon footprint reduction, basically alignment with European regulations, including all the information for materials through EPDs, etc., and lifecycle assessment. So what's BIMxel? BIMxel acts as a central semantic hub following the LOT methodology. This LOT methodology is a methodology developed also in Spain by Maria Poveda in the Polytechnic University of Madrid. And it allows us, this ontology, to unify the 3 data streams, which are the IFC data from the models, the external contextual data, and the sensors of the observations into a machine interpretable knowledge graph. The idea of working with a knowledge graph, I will explain you later on, but it was like an evolution of the project, because at the beginning we were not working with the knowledge graph. And in this BIMxel ontology, we include everything: our KPIs, location, actors, sensors, measurements. We have on the paper, you can also check this part, but it's a bit like the how we built this ontology, no? So we have all the data from the IFC, we have all the data from the sensors, and the external data. The different colors are related to the different ontologies. So for geography, GeoSparkle, from time, from weather, materials, etc. And that's the way that finally we all go inside this BIMxel. And afterwards, we connect to the artificial intelligence services. So about the LOT framework, how we build it. So the LOT methodology, it's a methodology that allows us to create an ontology in 4 steps. First one is requirement specification, in which we develop different workshops with the public administrations and developed all and created the KPIs. Then the implementation part, in which we developed we worked with OWL, the turtle format, And we did different iterative reasoning checks with Protege, then the publication in Widoco, and finally the maintenance in SACL. This was the first approach of our ontology, in which what we did, as I explained before, is that we were reusing existing ontologies in our ontology that it's the BIMxel. So at the beginning, we were working with IFC-OL, GeoSparkle for spatial and structural, SOSA and SAREF for IoT, temporal quantities for all, and QDT, and sustainability with basically with BAO. And there's a diagram of how the different classes were connecting each other. There was an evolution about that. Spoiler: we are not working anymore with IFC-OL because it made the models to be too heavy to work with them. But this is something that we will see on the validation part with the use case. For the validation results, we did a conceptual validation with SACL, logical with the Protege, structural with the Widoco, where it was published. We did the fair evaluation, and it got a low score, but this is because we didn't have enough data in the projects yet. We were still working with the first models that the public administration were sending us, and they were not super complete. So it was more about lack of data than conceptual or logical limitations. And then the SACL analysis that it was successful. So then we had the case study validation, in which we realized that we had to modify somehow our ontology. We kept working with QDT, SAREF, but for example, we stopped working with SOSA, and we did everything in SAREF for water, SAREF for energy, and this helped us, and it was like more coherent to be working with the same ontology in the different use cases. Then the BEO for building elements and for the distribution elements also, as we were not working anymore with IFC-OL. As I said, it made the models a lot, the turtle, the resulting knowledge graph in the turtle file was a lot lighter. And this was like the main change, that we decided to stop working with IFC-OL and then do the jump to the knowledge graph and using these ontologies. This is the resulting ontology as it works nowadays. So it's the evolution from the previous one after implementing the first use cases. So here you can see that we are working with our knowledge graph and what's the connection between the different types of information on it. This is one of the examples of one of our buildings at UPC in Campus Terrassa. So you have the GeoSparkle for the location, then the bot to contain the elements, and the SAREF for all the measures from the IoT systems. So discussion and limitation, we have still some limitation. First of all, we are just working with public administrations. Probably this could be implemented in other studies, but we are just working with this. Occupant behavior is something that we would like to implement in our ontology, but we still don't have the data, so we haven't started working on it. The ontology complexity is because, okay, the fact that we are reusing existing ontologies improves interoperability, but it also makes it more complex and increases the maintenance. Then scalability, at the moment we just have a couple of pilot projects. It has helped us to validate our current ontology, but it's still limited. And we still have to start developing the artificial intelligence services and its governance. That you know that it's always a problem. So here for the conclusions, you can have access to our ontology if you are interested on this link. BIMxel at the end demonstrates that a reuse-oriented industrial ontology can achieve the applicability for real BIM IoT datasets. And it enables portfolio level energy, water, and carbon queries with a unified knowledge graph. So thanks a lot.